be talking about ensuring food security through meal optimization. And yes, my name is Liselotte Schäfer Elinder. I'm a professor in public health sciences at Karolinska Institutet in Sweden. And I think that Patricia Eustachio Colombo, who is a postdoc actually in Cambridge right now, that she's also listening. Okay, yes, so I will be talking about diet and food production. Yes, okay. Because this is a very important matter for food security, of course. And food production has huge environmental impacts. Today, it occupies around 40% of all ice-free land surface. It contributes about 1/3 to all human-induced greenhouse gas emissions. And it's the largest driver of deforestation. It accounts for about 70% of the Earth's freshwater withdrawals, and it is driving nitrogen and phosphorus eutrophication and acidification of the Earth's ecosystems. And all these factors impact and threaten food security. So it is a matter of feeding the world, which we are just now becoming 8 billion people on the planet, and we are the foresight is that we'll be 10 billion by 2050. And when it comes to the Swedish diet, and I believe it's similar for the diets in your countries, the impacts are actually transgressing several of the planetary boundaries. And here you can see 6 of them. One is biodiversity, which is expressed as extinction rate. And if you look at the inner red circle, this is about where we should be at maximum. So this is the 100% that we should not cross. And when you look at extinction rate, we are about 5 or 6 times above this loss of biodiversity with the current diet. When it comes to greenhouse gas emissions, we are about 200–300% above the level we should be at. When it comes to cropland use, we are about at double the level. When it comes to nitrogen phosphorus application, we are at about 4 or 5 times higher. And in Sweden, actually, we are, when it comes to water use, we are still within the planetary boundaries. But this, of course, cannot continue, and especially not if the world's population is growing. And food consumption also has a lot of health impacts, of course. The current food consumption threatens the achievement of several of the Sustainable Development Goals. One of them is Goal 3, health, of course, but also zero hunger, which is the first one, and equality. And yes, as I said, several of the Sustainable Development Goals are threatened. And dietary risks account for just over 40% of all deaths from non-communicable diseases globally today. 1 billion adults are obese and 39% are overweight globally. At the same time, 2 billion people are nutrient deficient. 700 million people are severely food insecure. And 135 million suffer from acute hunger today, according to data from our World in Data. So we actually have several, as you can see, both environmental and serious health consequences of the way we currently produce and consume food. And in January 2019, just before the pandemic, or the year the pandemic started, the Lancet came with this report, Food in the Anthropocene, the Eat Lancet Commission on Healthy Diets from Sustainable Food Systems, saying that without action, the world risks failing to meet the UN Sustainable Development Goals and the Paris Agreement, and today's children will inherit a planet that has been severely degraded and where much of the population will increasingly suffer from malnutrition and preventable disease. So clearly a serious warning here that our food system is not healthy. And then in this report, they also had calculated a general diet, which could, a plate model, which could look like this, which is, of course, general for the world, but which has to be adapted to different cultures and countries. And it's called the Eat Lancet diet, which is evidence-based in the sense that this plate has been calculated from the scientific literature in epidemiological studies on diet and health, and can be said to be evidence-based. And if you look at this plate, half of the plate should be fruit and vegetables. And if you look at the little thing that is on the side here, I think you can see here is the protein part. And as you can see, the big change to the current diet is, of course, that the protein part consisting of animal-based protein is very small. And the major part of it is plant-based. So the big difference in this on this plate is that it is mainly plant-based, and the animal products have been reduced considerably. And this is a plate that is considered healthy from a health perspective, but it of course also is considered environmentally sustainable. So our national food-based dietary guidelines should be revised. They could be, according to a publication from Springman from the UK, they have looked at the healthiness and sustainability of national and global food-based dietary guidelines and have modeled how it should look. And what they say is that national food-based dietary guidelines could be both healthier and more sustainable, providing clearer advice on limiting, in most contexts, the consumption of animal source foods, in particular beef and dairy, has the greatest potential for increasing the environmental sustainability of dietary guidelines. And increasing the intake of whole grains, fruit and vegetables, nuts and seeds and legumes, reducing the intake of red and processed meat, and highlighting the importance of attaining balanced energy intake and weight levels are associated with most of the additional health benefits. So this is completely in line with the Eat Lancet plate, that we need to reduce animal source foods and transform our diet to be mainly plant-based. And the Swedish food-based dietary guidelines, we have 4 of them. We have, of course, nutrient recommendations, but these are the food-based dietary guidelines of about 500 grams of fruit and vegetables per day. And according to EAT, that is around the right level. Fish 2 to 3 times per week, corresponding to about 300 grams per week. EAT says about 200. But the biggest difference is in whole grain and red and processed meat, where we eat much too little of whole grain and considerably too much of red and processed meat, according to this evidence-based plate model. And we have actually then looked at the diet of Swedish adolescents and compared this to this Eat Lancet diet, which you see to the left. And there you can see fruit and vegetables, carbohydrates, the yellow, and protein is the reddish part here. And according to this Eat Lancet plate model, you can see what the protein part consists of. And the current diet of Swedish adolescents, as you can see, is quite different. There's a much larger protein part and a much smaller fruit and vegetable part, and about a similar carbohydrate. So you can say that Swedish adolescents consume, according to these new evidence-based plate model, they much too much protein, and a lot of it is actually animal-based protein. And you can see what needs to be reduced is this beef and lamb part, so the animal-based part, and legumes have to replace the protein part that is currently consumed from animal foods. And this is yes, so this is how it looks currently. And what we have then done in a study called OPTIMAT, and mat means food in Swedish, is that we have used optimization to look at what could this diet of Swedish adolescents look like if it were both healthy and sustainable. So we have used linear programming, a relatively simple way of optimization, to this diet to be as similar as possible to observed consumption to increase the acceptability. So this is our objective function. And then we have put constraints saying that nutritionally it should be adequate. And we have reduced the climate impact, so greenhouse gas emissions, by 65%, so that it would be similar to the level of greenhouse gas emissions adopted by the World Wildlife Foundation. And it should be similar or lower in cost. And then we have optimized 4 dietary patterns: omnivores, pescatarians, vegetarians, and vegans. And pescatarians are vegetarians who eat fish, and vegans don't eat any animal-based products. So we have been modeling the diet of these Swedish adolescents. And what we found is that if we only optimize it for nutritional adequacy, we reduce the greenhouse gas emissions in the omnivorous diet by 39%, in the pescatarian diet by 59%, in the vegetarian by 62%, and in the vegan diet by 73%. And this reduction in greenhouse gas emissions was mainly due to lowering of meat and increase in fiber and polysaturated fat. And as you can see, what it shows you is that the diet of Swedish adolescents is quite out of balance when it only comes to nutritional content. And you can also see that by eating vegetarian or vegan, optimizing their diets to be nutritionally adequate, but fulfilling these criteria of no animals products or no meat, we can actually reduce the greenhouse gas emissions considerably. But if we then optimize these diets, not only for nutritional adequacy, but also reduce the greenhouse gas emissions and the other constraints that we had, we could optimize the diet for omnivores. And here you can see that the protein part becomes much smaller now. And you can see that it looks quite similar now, or relatively similar to the Eat Lancet plate model. So this is the upper one is for the omnivores, and you can see what it looks like. And for the vegans, we actually don't have to reduce the greenhouse gas emissions more than it was already done when you just optimize it for nutritional content. So this shows you that it is fully possible to produce or to have diets that are nutritionally adequate, low greenhouse gas emissions. They don't cost more than the diet did at the baseline, and they are as similar as possible to the diet, to the baseline diet. So, and we have done a similar thing with school meals, also in the OPTIMAT project, where we have optimized. We have looked at the food supply in the current school meals, and we have optimized it to be nutritionally adequate, and we could ensure it or even improve the nutritional content of these meals. At the same time, we could reduce the climate impact by 30 to 40%. And reduce the cost by 9 to 11%. And the new menu was similar in terms of dish composition, and changes were mainly done within recipes. And when we tested these diets in practice, we found that they were consumed. The students were satisfied as satisfied as they were at baseline. There was no increased waste, and the consumption was at the same level. So this just shows you that it is actually possible to optimize these meals considerably and improve both nutritional content and reduce climate impact. Yes, no significant change in food waste consumption or school meal satisfaction by the students. So where does that leave us then? We we believe that the way we serve our public meals could be one way to increase both the sustainability and the healthiness of our diet. But the problem is that meal planning today is becoming increasingly complex because there are so many factors that we have to consider. Multiple health and environmental criteria have to be fulfilled. And we have to have knowledge on the nutritional content and environmental impact of each food item, which which we have today to some extent, but we still need to develop more environmental data on environmental impacts of each single food item. And of course, when we do, we should include data on all relevant nutritional, environmental, and cost indicators associated with each food item. And what we also think is that we should involve meal staff and customers in meal creation to produce tasty and culturally acceptable meals, because of course acceptability is a great an important factor for meal producers. They want their meals to be eaten, and we don't want to increase the food waste, of course. And then it should also be linked to food procurement systems, because this is quite a complicated matter to procure foods, and they have to fulfill a lot of criteria. So what we then have come up with, our idea is to take the help of artificial intelligence to help us in effective meal planning. And we have developed this idea of the OPTIMEAL meal planner based on evolutionary computation. And what is this supposed to help us with? It is supposed to help us to produce meals which are both healthy and sustainable and fulfill a lot of criteria simultaneously. So this is kind of a holistic tool that can help us to produce these type of meals that are both healthy and sustainable. So what we have here is a meal planner on the left side, who has some recipes that they want to use, and what we believe is that we should have a huge bank of recipes that are acceptable, tasty, and have been tested to begin with. But then the question is, how do we compose menus of these recipes so that we fulfill these criteria that we have set up over a maybe 4-8 week period? So we think that we want to develop this OPTIMEAL planner, which contains then algorithms and takes into consideration the climate impact, the food waste, recipes, user data, nutrition, land use, biodiversity, and other indicators. And then the algorithm uses, for example, could use evolutionary computation to produce a menu over, say, 4 to 8 weeks that is both sustainable, nutritious, cost-effective, and based on research. And in the end, the menu planner has his or her menu, and can, and then this should be coupled to a procurement system, and so that the user can procure the foods needed to produce this menu. And what is also an advantage with this tool is that many other special needs of the consumer can be taken into consideration, for example, allergies or other special dietary patterns that need to be fulfilled. So the idea is that to make it easy for the meal planner to produce these new type of much more plant-based menus, which we need for both health and sustainability in the future. And of course, we can think of possible settings to introduce this, schools, of course, but also hospitals, elderly care, everywhere where we have this type of public meals or meals served in different settings. And yeah, on the road to a sustainable food system, then what do we need? Or what do we have to consider? That current diets and food-based dietary guidelines are far from optimal regarding health and environmental impact. Diets can be realistically optimized to meet both nutritional requirements and environmental goals, but it is an increasingly complex task. What we would like to see is to develop digital tools using AI to promote sustainable meal planning and procurement. And we also think that we should capitalize on the normative power of public meals to promote a more plant-based diet, thus ensuring in the future food security around the globe. And yes, this was what I had to say. And if you are curious to hear more about this, you can contact me or my colleague Patricia Eustachio Colombo at this mail address. I think that was all I had to say.